Hello friends, welcome back. So in this session we will learn argument conversion in JUnit 5. So what we have seen in the last session, we have seen parameterized test case, and for this parameterized test case two components were mandatory. One was @parameterized test annotation and another one input source that can be used to take the input, and input source can be a value source, null source, empty source, null and empty source, enum source, method source, CSV source, CSV file source and argument source. So now what challenges we are getting? Suppose we are taking the input from the source, and that input we are taking in form of method parameter of test case. Whatever the test case method we have created, in that method only we are giving some parameters, and that parameters we are considering as an input. So sometime what happen, the value is coming, whatever the value is coming from the source, that source can be anything, that can be enum source, method source, CSV file source, CSV source or argument source, that can be anything. But whatever the value that is coming from source, that may be differ from the argument of test case method. So in that case what we have to do, we may need to convert that to specific type. Sometime we may need to convert, sometime it is automatically happening. So that is only the requirement of argument conversion. We have to do argument conversion. Sometime it is happening, sometime implicit is happening, but sometime if it is not happening, then we can do so. We have that features also, that possibilities are also there, and that functionality is also defined into JUnit 5, so that you can do the argument conversion. So there are some type of argument conversion. First one is a widening conversion, that we have already seen in our data typecasting. In our typecasting session we have already seen. In typecasting, implicit typecasting, explicit typecasting, narrowing, widening, all those we have seen. So you can watch that session again and you will come to know what is widening, how it will automatically happening, what is narrowing. So all those are defined into that one. But so if you want to see here one example, then you can consider our previous example, like parameterized test demo. Inside that one we are taking here one input. You can see this method, you can see this one here. What we are doing, we are taking input from this value source, that values are integer only currently, 1, 2 and 3. These are integer only, and we are collecting into integer only. But we can do here long, no issue. If we do here long, then also that is fine. Yeah, that is also fine, you can consider this one. Okay, so so here this is 1, 2 and 3, that is type of integer only, but inside our test case method we are collecting as a long. So it is fine, that will work, no issue, because this is only the widening. This is only widening. Yes, see, 1, 2 and 3, it is taking value source test only. See, if I give here double, that also fine, it will because this is only widening we are doing here. So we can do that automatically, because there is no role of this JUnit here. Automatically your JVM itself is doing, your compiler itself is doing this. You no need to worry about that one. See, now it is considered as a double. So that is fine. That is only the widening. That is only the widening. Suppose JUnit.Jupiter supports widening primitive conversion from argument supplied to a parameterized test. For example, a parameterized test annotation with the value source int 1 2 3 can be declared to accept not only the argument type int but also an argument of type long, float or double. That is only widening. Okay, next one is implicit conversion. Implicit conversion means some from some value your JUnit 5 platform is inferring or by default. Suppose if you give here boolean and this boolean if you are giving as an input, as an resource, means inside resource, you can see from this example. So here you can, if you specify from the resource true, but this true is considered as a string only. But if you want to, if you declare your parameter type as a boolean, then definitely it will be converted like that only. So that is only to support use case like CSV source. JUnit.Jupiter provide a number of built-in implicit type conversion. JUnit.Jupiter provide a number of built-in implicit type conversion. The conversion process depend on the declared type for each method parameter. For example, if parameterized test declares a parameter of type time unit and the actual type specified by the declared source is a string, then string will be automatically converted into the corresponding type if it is meeting the requirement of a unit time unit, because time unit is one enum. And for this enum so many constants are defined into this enum class, and for that enum if you are giving a value as a string, if it is matching with the name of constant, then definitely it will automatically converted into time unit. Automatically it will infer. So this is the meaning of implicit conversion. So let's have some examples here. So here if you see this first one, if you see here, so here what we are making, we are taking value source of type string. Value source we are using, and that source is giving the input in form of string only. Here it is a string, but what we are expecting here, we are expecting here chrono unit. This is one enum that is available under java.time.temporal.chrono unit. We have already seen those time date and time API. So this is one enum. So for this enum, like hour, minute, seconds, so many constants are defined. Here you can see here minute, second, milliseconds, hour, half day, week, month, so many are there. So currently this string whatever is coming from the input source, that is matching with the name of chrono units. Any one name it is matching, so definitely it will automatically converted into chrono unit. So this is called implicit conversion. Implicit conversion only. If you run this one, you will see we will get the parameter as chrono unit only. See, it's executed successfully. Implicit argument conversion test, this only, implement argument conversion test only, seconds. It is second, name is second, because this is a type of chrono unit only. So this is automatically converting. This is called implicit conversion. So this is one example. Same thing you can do for month. Suppose here month is also one enum that is defined under java.time API, and for that month January, February, March, April, like that 12 months name are defined as a constant. So currently this April is matching with the name, so it will automatically infer and it will create. So this also will work fine, no issue. Yes, it's working. If I give here instead of April R something I will give, this time it is not matching with that one. So what it will do, it will throw an error. See what error you are getting here: failed to convert string April RR to type of months. It is a failed, cannot convert at all. See, error converting parameter at index 0, failed to convert string April RR to type java.time.month. So it will not convert. If it is a matching, then definitely it will convert. So this is called implicit conversion. Automatically it is happening on the basis of input. If it is a matching for a particular type, it is happening, otherwise it will throw exception. Okay, so this one is fine. Next one is this one. This is also implicit conversion type only. See here, whatever the type we are taking here, so here what is the input value? Input value is in form of string only, but the parameter we are taking as an integer. You can see here in this method, if you see the value source we are using, and for this value source input type we are specifying as a string, array of a string only. String is 1 2 3, but currently you can see this string is a numerical string only, 1 2 3, that are numerical string, and we are collecting in integer only. So we are collecting in number, so it will automatically infer and it will do the implicit conversion here also. Okay, if I run and you will see, see 1 2 3. So like that implicit conversion will automatically happen. To support use case like that, resource can be anything. You are taking example of CSV source here, here it is taking CSV source, so any source it can be. And Jupyter, unit Jupyter provide a number of built-in type conversion process. Okay, so here they have given some example, like this is our target is what? Our target is a boolean. We are taking we want to take input in form of boolean only, but exact value is we are giving as a string, that is a true, so it will automatically converted into boolean. If it is a byte, like this value we are taking, then it will be definitely converted into byte. If it is a character, then this string, if it is a string, then definitely it will be converted to character only, it will be converted short, like that it is giving for all. For enum, if it is we have seen this example already, it will be converted into this enum. If it is a file, but currently we are giving a path of file. See, it is very interesting. This is a path only, but this path name is given as an input, but this path is given in form of string only. And but if you are taking if you are converting, or if you are accepting that that input in form of file only, then automatically it will be created a file using new keyword. See, if it is a class, suppose you are giving this is one, then definitely it will be converted into java.lang with class only, integer.class, nested. Okay, so this is the example, so it will be converted to class only. Or if it is a big decimal, then this number will be converted to big decimal. Big integer, it will be converted to big integer. If it is a URI, then if you are giving this one is the URI, but that URI is you can see here in form of string only, definitely it will be created a URI in this way. Okay, so like that they have given for all, like path. For duration, this is a duration of 3 seconds, because you know this is a time of 3 is what? Seconds only, so duration of 3 seconds, automatically it will be converted. but it should match the criteria, it should match with the value of a particular type, then only it will do. Instance, local time, this is our local time, local date time, this is local time, month, if it is a month then both it will be accepting. Okay, month, day, offset time, year, this is in year, this year will be converted to this year simply. So this is called implicit typecasting. Currency, JPA, this is the currency of JPA, get instance of currency dot get instance, we have already seen this currency class. Local class we have seen en, if we are giving en then local will be created using new keyword. So like that this will be, this implicit conversion will be happening. Okay, and the next one is explicit conversion. So what is explicit conversion? Instead of relying on implicit argument conversion, you may explicitly specify an argument converter to use a certain parameter using convert with annotation, like following example. Note that an implicit argument conversion must be declared as either a top level class or a static nested class or outside any classes. Okay, suppose so if you want to do explicit conversion, see this is implicit conversion, automatically this is a string but it will be converted to number, because you are taking this taking this in form of integer array only, integer argument only. Here this will be converted, this is also string and this is also string, you can see here this is also string, this is also string, but this will be converted into enum because you are taking argument as an enum. But here this will be converted into integer because argument you are taking as an integer, but it should match the criteria, then only it will automatically converted to respective type. This is implicit conversion only. But to do explicit conversion, explicit argument conversion, what we have to do, we have to specify the converter. Here this is inbuilt converter, Java time conversion parameter, Java time conversion parameter. So this is one converter they have given implicitly, means inbuilt, sorry, they have given that converter inbuilt converter, actually Java time converter parameter, and this converter is taking the that parameter, so here this Java time converter pattern is accepting one string that is defining the pattern. So this pattern it is accepting, and using this Java time converter pattern your string will be converted to local date. And if you give local date time, then also that will be fine, because you have to specify that pattern here, and that in that case this string should follow the pattern of date and time both. Currently we are taking as a local date, so local date is day, month, year, so this is our pattern, and in the same pattern we are giving this string, so it will be converted to local date from this string only. So if I run this one, you will see this test case will be passed, and here it is, this assertion also will be matched. See, so now this is a date. Here the argument type is local date only. So this is explicit argument conversion. But currently if you see, this converter is given inside your JUnit API only. They only have provided these annotations. But if we want to give our custom argument converter, then how we can do? In that case, what we have to do, we have to use convert with annotation. We have to use convert with annotation. Here if it is specifying you may explicitly specify argument converter to use for certain parameter using convert with annotation. Convert with annotation. So what we are taking here, so here my simple argument converter I am giving, and using this converter only I am converting to string. This chrono unit I am converting to string only. So if you see here, what is the code inside my simple argument converter? My simple argument converter is the subtype of simple argument converter, and the simple argument converter is provided into org.junit.jupiter.params.converter. Under this package only this simple argument converter class is present. So this class is an abstract class, and if you implement this one, you have to override convert method. You have to override convert method, and that convert method has a signature like that. The return type for that one is an object, super type, and two parameters means this is the type, this is the type that we are taking from the resource, from the source. So currently what is the source type? If you see here, sorry, not this one, yeah. So what is the current type that we are taking? Current type is an chrono unit, chrono unit only. Okay, so here this is a type of chrono unit only. And what is the this is the type, this is the type means chrono unit. And what is the value for that one? What is the value for that one? The value of that one will be all chrono units, like that nanos, micros, miles, seconds. So that will be the input for that one. So that input, what we are doing, if we are checking that is an instance of enum, then we are taking the name and we are returning the name. That's it. We are taking the name of that one. Simple. First what we are doing, we are typecasting to enum, and then we are getting the name. Otherwise what we are doing, we are applying value of .toString simply. So that it depends on the type. Whatever the type you are taking, from that one you have to parse very smoothly, you can say like that. You have to very carefully you have to parse what type you are expecting. That type only you give here. So currently what is the type for that one? Currently the type for that one is enum source. So if it is an enum, then definitely we have to process in form of enum only. So we are processing as an enum only. If this can be a student or person or any other type, then that type only we have to give here. Or if it is a string or something like that, then, and we are giving in form of string only. So that's why it is converting into this chrono unit. This enum will be converted to string here and that we are chrono unit of asset node null chrono unit of, yeah, that is fine. You just give just check with this value only, no issue. Argument only, that's it. No need to do this chrono unit value of that also, because that is a string only. Our motto is to get the value from the enum and transfer that into string only. So it is happening. Okay, let's run this one and we'll see. Yes, so it is taking all decade, century, million, millennia, era, forever. So all it is taking. Okay, that is fine. That is fine, up to your choice. However we want to process, whatever the implementation we want to give, we can give here, no issue. that is in our hand only. Okay, so this is the explicit conversion. But currently you are seeing very one difficulty we are facing. What is that one? Here this is a super type object, here also this is a super type, so it is very difficult to process. So this this abstraction, this one we can remove using what? Using generic. And for that purpose, what they have given an another class. They have given an another class that is type argument converter, and this type argument converter is also available under org.junit.jupiter.params.converter. Under this converter, this class is available. This type argument converter abstract class is available, that is a generic. So here you can specify this first one is your input type. This first one is your input type, whatever the type of input you are taking from the resource. Currently our resource is value source, our input source is value source, so that is value source, and that value source is a type of what? String only. So that is our input type, and to what type we want to convert this one? We want to convert that into integer. So one we want to convert into integer. How it is possible? Or you can give it int, or you can give integer, that is fine. Integer or int you can give, no issue. Number, that's it, that is also fine. So you can you can convert into string also, integer also. From the string we are converting, and what now we are converting with the help of what? With the help of our custom converter, our custom type argument converter. And custom type argument converter has one convert method that we have to override, and we have to give one default constructor that will call the super constructor of type argument converter, that we have to call here. What we have to do? We have to give one default constructor of our subtype, of type argument converter, and inside that constructor we have to call the super constructor of type argument converter class, and that will take two generic argument, whatever the argument we are specifying here, string and integer we are specifying. Okay, and we have to override the convert method, and this convert method will take one parameter, that is a source, whatever the input type, and it will return a generic argument that will be type of output, whatever the type we want to convert. This is our input type, this is our parameter type that we want to convert. So here how we are converting? If this source is null, then that definitely I am returning 0. If this source is matching to numerical string, this is our numerical string only. So if this source is matching to numerical string only, then only I am parsing to integer dot parse int, and I am returning. If it is not matching with this regular expression, in that case what I am returning? I am returning the length of that one. So here if you see these all will be converted to integer only. These all will be converted to integer only with the help of my typed argument converter. So what will be the value of 1? This 1 definitely it will be 1 only. This 3, this will be 3. This 9, it will be 9. This 4, it will be 4. But what will happen for this hello? Because I have given the implementation in this way, it will return a length. If it is not matching with the regular expression, if your string is not a type of numerical, if your string is not a type of numerical, then I am returning the length of that one, because length will be numerical only. So here what will be the value for this hello? It will be 4, hi 2, Java 4, computer 7 or something, 1 2 3 4 5 6 7 8, and this 7 7. And if it is an empty means what will happen? If it is an empty, then definitely it will not match this one. It is not null, but it will not match this one. If it is not matching with this one, then definitely the length will be 0, will give 0. Okay, so if I run this one, you will see the actual output. Okay, so like that you can do the conversion of a parameter from the input source. What happened? Oh, sorry. Okay, this you cannot give int, you have to give integer only. Okay, because the exact type you have give you cannot infer like that. Your compiler can infer, but you cannot infer in this way. Okay, yeah, it's fine. See, 139 4 5 139 4 5. After 4 5, after 4, what is that one? After 4 5 is there, hello is 5, then hi is a 2, then Java is 4, then 8 is computer, and then 7, next one is 0, simply. So in this way we can give the explicit conversion. Explicit conversion we can do using convert with. Inside convert with, we have to give the converter. That converter can be the subtype of subtype of my simple argument converter. If it is a my simple argument converter, then that will always return an object super type only, and it will take also super type only, and here we have to specify the class also. But if we take my typed argument converter, then that process will be very easy, because it will exact type it will return and exact type it will take. So we can make our custom converter using with the help of type argument converter or simple argument converter, but we should go with the type argument converter only, because that is the better in term of cleaning code and in term of performance also, because here you have to make the comparison. Definitely you have to make the comparison if this is the instance of this one, but here you no need to do that one. Here we are not doing that one. Okay, so like that we can give the explicit conversion for the argument. And okay, and the next one is argument aggregation. What is argument aggregation? Argument accessor can be used instead of multiple parameter using the API. You can access the provided argument through a single argument passed to your test case. How it is possible? See, currently here if you see this is our value, this is our input source, value source, that is a type of string only, and our argument is nothing but we can give here type of string. That is fine. We can give this as a string also. It will work very much fine. In that case, this argument, that will be nothing but that will be a string only, that will be word only. See here, get string will not be there, only string will be there, simple. That will be fine, it will work. If I will just give here argument, that's fine, and if I run this one, it will work. Yes, you can see namaste, hi, hello, swagatam, welcome. So this string, it is taking in form of string also, but instead of that one we can use argument accessor. Argument accessor, what will do in case of, currently this is a one string only, so that string it will come into argument accessor, and from that one you can get string using get string of a first position. You will get the one word, simple. That is also fine. But this argument accessor you should not use for single value, because unnecessarily you have to call one method get string of 0, then only will get. Instead of that one you can give string, simple, it will come. But this accessor is useful in form of CSV source. In CSV for source we know CSV is nothing but comma separated values only. So here if you see, this is our one input, this is our one input, this is another input, this is our one input, that is our another input. So in that case what we have to do, we can single argument, we can accept that values into a single argument, because this is one only. And using this one, if we get into string, then definitely by comma separation we have to split them, and after splitting we will get. So all those functionality we have to do manually, but we no need to do manually. We can use argument accessor, and from this argument accessor get 0, get 1, get 2, get 3, you can get like that. Get 0 what? Get 0 what type it is? String only. So get 0 means string is, first name is Harish, so get string first name Harish will come, last name Kumar will come, get string of first one Kumar. Third one is a character only, so get what is that one? Character. Get second 0 1 2 third. And what is the type of that one? This M is a type of character only, so I am taking into character. Last one is a date, so I am getting as a local date. Get local date. Here you have to specify the type, here you have to specify the index. Simple. Because this resource is a CSV means that will be split by comma, so that's why you can get using this index 0 means Harish, 1 means Kumar, 2 means M, and 3 means this date of birth. Simply you can get in this way, and that just I am logging here and just I am checking assertion not null. Simple, you can do in this way also. Okay, so that is nothing but argument aggregation. We are making the aggregation of argument. Okay, let me run this one and you will see. Yes, it is working. See, Harish, Kumar, male, date of birth, then Shri, first name, Devi, last name, gender, male, and this is the date of birth. Simple. So you can use accessor instead of multiple argument. If it is a multiple argument, then definitely what we have to do, otherwise what we can do in this way. String first name, string last name, string last name, character, gender, local date, something like that. In that case that is also fine, it will work. But instead of multiple argument, simply you can take argument accessor, and from that argument accessor you can read. That is also fine. Okay, so this is the argument accessor, and here if you see, you can see one more argument accessor. You can use argument accessor and aggregate with your argument accessor aggregator. You can give aggregator also. Currently see, this is a one value, this is a CSV source only. We are taking input from the CSV source, we are taking the input from CSV source only in form of comma separated values, that is strings only. But this is, you can see, this is complete person object. Yeah, this is a completely person object. First name, last name, gender and date of birth. First name, last name, gender and date of birth. So this is, it's looking like a person. So I have just created one person class like that. First name, last name, gender and date of birth. Simple. You can say this is a Pojo class or DTO, data transfer object class. You can say like that. This is our DTO. Okay, so this is just getter setter method is there, and with some fields. This is just a simple data class. Okay, and that data, this input data, I want to convert or I want to aggregate with person. How I can do that one? I have to use aggregate with annotation into method argument. Into test case method argument, I have to use aggregate with annotation, and this annotation is taking a class reference of what type? Class reference of argument aggregator type. What is argument aggregator? Argument aggregator is an aggregator that is available under org.junit.jupiter.params and .aggregator, that is available under this package only. So that is nothing but an interface, and that interface has one method, that is aggregate arguments, and that is given two parameters and one return type. Return type, whatever the type you can give. Currently this type is a person. You can give any type because this return type is an object, because person, you know, that is a subtype of object only. So what I am doing here, I am using this here, get argument of 0, get argument of 1, get argument of 2. Here string you can use like that also. Argument dot get string, just specify the index number, simply it will give string. Argument dot get integer, just specify the index number, it will get. Or else you can use this one. Here you have to specify the index number, and here you have to specify the type. In the both way you can get. Okay, and just return the person. So here that only what we are doing here. See here, if I run this one, you will see it will be converted into person only. Yes, obviously this is converted to person only. This is a person object. Yes, and here see here, this argument is there, argument accessor. From this argument accessor you can use get string, or directly one method is there, like get integer, get boolean, get float, get double, get get string, get short, get byte. So all the methods are there. You can directly get of a specific type. If you don't know the type, then you can just use get, and under this get you have to specify the index first, then you have to specify the type here, type dot class. Any type means that can be local date, character date, string date, anything. Okay, so like that you can use this argument aggregator. Okay, so in the next session we will see dynamic test in JUnit 5. So I hope you like this session. Please subscribe my channel, and we will see you in the next session. Till that, bye bye, and thanks for watching.